Okay, we are talking about solving equations with one variable. Oh, sorry about that, you guys. Solving equations with one variable, and there's special cases. So you received this packet at the door. So I want you to take this packet. You're going to need your scissors and glue stick and your notebook. So you're going to split this. You're going to cut these tabs out. Now I didn't realize this when I printed it off, but you won't need these down here. So just cut those off. We'll put those in the basket, or we'll collect those. I can use these again for our another class, a Math 8 class. So don't throw that extra piece away. You're going to then cut those out, and you're going to glue the one solution, the two, no solution, and the infinitely many solutions, the 1, 2, and 3. Glue 1, 2, and 3. So it ends up looking like this. Now, you can also spend some time, if you want to spend some time coloring, make it look really pretty. You can also do that kind of stuff at home, but pause the video right now, get caught up with cutting, pasting, doing a little coloring if you want. There's some color pencils, but don't spend all your time in class today doing the coloring part. You may do a little bit of that at home. You can use highlighters. A lot of times I'll use highlighters too to kind of make it look a little faster. So pause it, get caught up there. Okay, you're back. Now, this is what I want you to do. By the time you're done here, you're going to be able to do this. And so this I can statement, I can determine the number of solutions of one variable equations. So when equations are written with one variable, you're going to be able to determine the number of solutions that that equation has based on information that you see. So right here we have our case number 1, our one solution. So I'm going to read it, and then if you pause it, then go ahead and copy what it says here. Let A be a real number, then x equals A. The value of A is a constant. So I know that sounds confusing, but the example is, so far everything you've been working has one solution. Like you've got it down to a variable equal to constant, x equals 5. That's a one solution. Only one number works in your equation. That's what we've been working with so far. No solution. A no solution, let A and B be real numbers, then A equals B. So I'm just saying these are real numbers. Yes, there are imaginary numbers. You're going to see that in Algebra 2. But A equals B. This is a false statement. Like for example, 4 does not equal 7. If your equation comes down to two constants that don't equal each other, that's a false statement. Infinitely many solutions, our third one. Let A be a real number, then A equals A. This is a true statement. Example, when 8 equals 8, or a constant equals a constant. If it's the same constant, that is an infinitely many solutions, meaning every number works. So right now, I know that went fast. Pause it, write those down. There's no reason why those are not written down. It'll make more sense when you get down here to solve the equations. All right, so now you're back. Now, we have our equations here. So this is going to be an example of a one solution. This is what you've been working with so far. And remember, variables on both sides. I don't need to do any other simplification. There's no parentheses. There's no distributive property. There's no combining like terms. So I can go right into solving it, into manipulating the numbers to get the variables to one side, constants to the other. Again, I like to move the variable terms first and keep them positive if possible. So I already wrote this out. So I'm just going to work this here. Negative 6x, negative 6x. I'm doing the inverse operation here. Then I'm going to bring down the 3 equals 2x minus 21. And then I have, then if I brought my variable terms this way, I'm bringing my constants that way. So I'm going to add 21. 24 equals 2x. Divide by 2. And my x equals 12. That is an example of a one solution. Your variable equaled one solution. There's only one number that works in here. Okay? Sorry, guys. So now, let's go ahead and we're going to use the distributive property. So here to simplify this, so we have 8 times 5x minus 2. We have 40x minus 16. Then we have 320 plus 40x. I like to move the variable terms first. You might notice something right here, but when we subtract 40x, you guys, that's gone. 40x minus 40x is 0, not 1 and not x. So those are canceled. We have a negative 16 equals 320. Well, negative 16 doesn't equal 320. I would love negative $16 to equal $320, but it doesn't. So false, that is a false statement, and it's a no solution. There's no number you can put into either one of those and make that true. Okay? So our last example, infinitely many solutions. Distribute first. Don't make the determination what type of equation it is until it's everything simplified on both sides. So I'm going to distribute both terms. The 3 times 2x is 6x, 3 times 4 is 12, 2 times 3x is 6x, 2 times 6 is 12. So I have 6x plus 12 equals 6x plus 12. So you might see right there, that's the identical expression on both sides. That's what we call an identity problem. They're identical on both sides. Well, if you want to go ahead and subtract the 6x on both sides, you do get down to 12 equals 12. That is a true statement. So this is infinitely many solutions. And I'm okay with abbreviating it IMS. Okay, infinitely many solutions. Okay, so on the back page, I'm going to have you practice. Now, I did this, but then I messed up on the last one, so I'm going to cover this up real quick and rework the last one for you. And I'm going to say something about your checking. When you have infinitely many solutions or no solutions, your checking, don't immediately just do this and write NA, because you've got to determine if it's a one solution, no solution, or infinite many. So don't ignore this for right now. Ignore that. Now, so go ahead and distribute on this. Now, I went ahead and cut this, and I pasted it in. I haven't colored it yet. But we're going to have 2x plus 2, so that's going to be 6x plus 4 equals 5 plus 6x. Subtract the 6x, and then you get 4 equals 5. Is that a true statement? No, it's a false statement. So that's an example of a no solution answer. Please write no solution. Do not just leave it like that. You let me know what type of problem that is or what type of solution. There's no solutions. Now, checking. You're going to write NA on your checking for no solutions because there's no way you can check it. There's no number that's going to work. So you can prove all the numbers that won't work. Well, every single number won't work. So you write N/A, which means not applicable. It doesn't apply. So N/A. Okay, second one. Let's look at this equation. 4x minus 1 equals 2 times quantity of 2x minus 3 plus 5. Distribute first. I never make the determination what type of problem it is until it's all distributed in combined like terms. 4x minus 1, 4x minus 6 plus 5. And so that is 4x minus 1 equals 4x minus 1. Notice that they're the exact same thing. So this is an identity problem to where you can go ahead and subtract the 4x if you'd like. Or right there at this statement here, you can determine it's a true statement. And it's an IMS, infinitely many solutions. Again, the checking. Now, you could check this. You could pick any number, and it will work. It should work. But if you don't want to, you can go ahead and write N/A on your checking. Okay, this is where on my last problem I messed up. So I'm going to redo it on another piece of paper here because I distributed wrong, and I didn't do the 2 times 8, so I apologize for that. So here we go. So on this one, we have negative 1x. Now, if you're still listening at this time, would you go ahead and write down the word giraffe right here, just so I can see it, to see if you're really listening or if you're listening to music and acting as if you're listening to me, because I have a lot of good things to say. So write the word giraffe. That's kind of your secret word. I'm not going to write it so I can see the ones who are, figure out who's really listening to me. All right, so the opposite of x, this is a negative 2. Negative 2 times 8x is a negative 16x minus 2 equals 7x minus 2 minus 12x. So remember, that's a negative 2. Distribute that negative 2 correctly. Now, I'm going to combine like terms. So this is really a negative 1x. Negative 1x minus 16x is a negative 17x minus 2 equals, now that's a 7x minus 12x. So be careful, that's a negative 5x minus 2. Okay, so I'm looking at the variable terms, and I'm going to see which one I need to move to make it positive. I'm going to add the 17x, add the 17x. I'm going to get negative 2, 12x minus 2. Okay, then I'm going to add the 2 this way. Ooh, careful on this problem. 0 equals 12x. Now, you guys don't flip out about this because this is one of those problems. A lot of people say there's no solution. Actually, there is a solution. The only number, now 0 divided by any number besides 0 is going to be 0. So x equals 0. There's a 1 solution. So the only number that works in this one is 0. And the way you can tell is if you get it all simplified right here. Your variable terms, if they're different coefficients, it's 1 solution. No matter what else is happening, it's 1 solution. So you could go back through and check this. Well, the opposite is 0 minus 2. I'm going to do parentheses. 8 times 0 plus 1, parentheses. Oh, this is really not easy to check on this page. Equals, let me do one side and we can do the other. So this is going to be, it's going to be 0 because you're going to be multiplying everything. Negative 2, 0 plus 1. Well, that's 0, so that's going to go away. I'm not going to write that again. And that's 0 plus 1 is 1. Actually, it's not going to be 0. It's going to be negative 2. Let's see if this side does negative 2. I'm going to do this down here. 7 times 0 minus 2, 1 plus 6, the bracket, times 0. That's 0, so that goes away. I'm not going to write it again. Negative 2, parentheses, 1 plus 0, negative 2 times 1 is negative 2. Sorry about that. But that did prove that 0 was the solution because it came out to negative 2 equals negative 2. So that's what I want you to work on. Your assignment, hopefully you really did pay attention in class and made sure that you worked on the 4 through 16 even over the weekend. And now you're doing 19 through 27 all and 28. And so what's going to happen in your book, 19 through 27 all, sorry, I had this ready and then I moved it. Write the problem, and then you might be able to see immediately if it's going to be a one solution, a no solution, or infinitely many solutions. I do want you to solve it. Like there's some that are going to be one solution, so don't just assume they're all no solution or infinitely many. So 19 through 20 is those type of equations. 25 and 26, you're looking for errors. Find the errors. Those are great problems. You're going to see one of those on the test, just a little hint. 27, set up an equation to solve. Think about your number of months that these are going to be equal to each other. And then number 28. 28 might be a little tricky, but you may work on that. So that is due tomorrow for when we come back to school. So that's going to be due tomorrow. Thank you.